In this video, we are going to implement PageRank using random walk. So let's start the code. As I told you in the previous video, there are 4 steps which are to be implemented, and out of those 4 steps, first, third and fourth steps are the same that we implemented in our previous video on implementation of PageRank using points distribution method. So we're going to reuse that code, and there's no point of writing the code again. So I've copied pasted the code which is required over here in this file. Let me show you. We'll start from the first step. First step is to take a directed graph. So as we had created the graph, how had we created? We had taken an object of nx.dieGraph. So we created an empty directed graph here, and after that we added nodes to it. We added 10 nodes to this graph, and after that we added edges to the node to the graph using this function add edges. So let's go back here. This add edges function I have copied as it is from the previous code. So here just to brief out, we are tossing a coin for every edge, and if the coin turns out to be head, we are adding that edge, otherwise we are not keeping that edge. So that's how we are randomly assigning edges to the graph. So after this, our graph is ready and we can perform a random walk on this. So that is the second step, performing a random walk, which is to be done. We'll just do that. After performing the random walk, we'll be having random walk points, and then we have to rank the nodes based on random walk points, which is what we done in the previous video. I've just pasted the code. I've just renamed this function get node sorted by random walk. I just renamed it here. That's all. The functionality is entirely the same. So this function I have added as it is. Okay, so that part is done. And finally, once we are done, we use the PageRank method from NetworkX, and we compare the results, our results with the function's results. Again, this is entirely the same code. Okay, so what has to be done is the second step, which is performing a random walk. Now let's do that. So this function is going to, we're going to create a function random walk, and that function will return random walk points. Okay, so let's write that random walk points is equal to random walk. So we are going to create this function random walk. We'll pass the graph there. Okay, so let's create this function. Okay, now as I told you, what do we mean by random walk? We will randomly choose one node from all the nodes. That is the first step. Okay, how do we do that? Let's get a list of nodes firstly. So let's write nodes is equal to g dot nodes, because we have to choose one randomly. We will choose one out of these out of this list. And as and when we visit a node, we increment its counter, increment its random walk points. So it will be nice to create a list which will be returned by this function. Random walk points is equal to, we have to initialize it to 0. So we can write 0 for I in range g dot number of nodes. Okay, so random walk points initialized to 0. Now we have this list of nodes, and we have to choose one out of these nodes randomly. So we can do r is equal to random dot, we have to choose one node randomly out of this list. For that we can use the function random dot choice out of nodes. Okay, so we got one node uniformly at random. Since we have visited it, we have to increment its counter, its points. So we will write rw points for this node r have to be incremented by 1. Okay, after that we have to look at the nodes which are neighbors to this node. Okay, we have to choose one neighbor uniformly at random. So let's first get a list of the neighbors of this node r. How do we get that? For a directed graph, we have a function g dot out edges. Okay, g dot out edges for r. Out will contain a list of all the edges, out edges from R. Okay, and after that we have to choose one of the neighbors uniformly at random, and we have to repeat the same process. So basically whatever we are doing, we have to keep repeating it. How many times we should do? As much as possible. Okay, so let's create a counter for that, and we can start a loop because we have to keep repeating things. We can take a very big number, probably whatever, as much as you can handle. I've taken this big number, so we will visit these many nodes. So we will basically have these many iterations of our random walk from one node to the other. So you can keep any number here. The basic idea is that we should be able to visit all the nodes. There should not be nodes which we have not visited, because if we don't visit any nodes, the counter for them will be 0, and hence we will not be able to rank the nodes properly. So the idea is that we should be able to visit all the nodes, and that too multiple times, so that we are able to capture the frequency of visiting in our counts, in our random walk points. Okay, so what do we have to keep repeating? We have started the loop. What do we have to keep repeating? We had reached R, and these are the neighbors of R. We have to choose one uniformly at random out of them. Okay, so that's what we'll do. Before that, what if this out is 0, the length of out is 0, that is the node which we have reached has no outlinks? That may also happen, right? And I told you, in that case, what do we do? In that case, we do teleportation, that is we choose one node uniformly at random from all the nodes. So let's check that. If length of out is equal to 0, what am I doing? Okay, if length of out is equal to 0, what do? We have to choose one uniformly at random. Let's create a new variable for that, to keep the node which is currently under focus. Okay, this focus will contain the node which is currently under focus, which is currently being visited basically. So we have to choose one node uniformly at random from all the nodes. So we'll write random.choice nodes. Okay, this is the list which we already created. In case the node which we have reached at has a number of neighbors, what do we have to do? We have to choose one neighbor out of them. So maybe we can have another random variable here. We can write r1 dot random dot choice. Now this choice has to be made out of what? This choice has to be made out of out, because out is what is containing all the edges, and we'll choose one edge out of them. Okay, now what is going to be the focus? The focus is not going to be the edge. The focus is going to be the node which is on the other side. How do we get the node which is on the other side? Using r1 1, because r1 0 comma r1 1 is basically the edge. Okay, yeah, exactly. Okay, so we got the focus, where focus is the current node where we are currently. Since we have reached at this node, we have to increment the random walk points for this node. So we'll write random walk points for focus plus is equal to 1. Okay, now again we have to get the list of its neighbors. So we'll write out is equal to, we can copy paste this, just that r will be replaced by focus, because focus is what is the current node. Now this is one iteration. What is this iteration having? This iteration consists of looking at the neighbors, choosing one out of them randomly, and then repeating the same process. That's what this while loop is doing. Let's implement the count. C, that is the number of times this while loop will continue. Okay, I think we are done. So what do we have to return? This function should return random walk points, right? So let's return this. I think we are done. Let's go down to the main. In the main also we have implemented everything. we only had to write this instruction. Rest all are the same from the previous code. I think we are good to go. Let's check whether this code works. So as you can see, the outputs 9246 and here 9264, and rest of the values are matching. So there can be two reasons for the mismatch. One could be the rank of 4 and 6 might be same, 4 and 6 here and 6 4 and 4 here, so they can give different ordering. Second reason could be that we needed more iterations so that we were able to visit all the nodes properly and we could achieve the effect. Because random walk is basically based on probability, right? You randomly choose the next node. It might so happen that you are ending up reaching one node more than the other node, whereas they both have the same number of inlinks, right? So that may happen. Let's check another example. Again here everything is same except 8 2 and 2 8 over here. We can check one more. So in this case, as you can see, it's precisely the same. Everything is matching. So it might happen because it's based on probability, and it is never possible that there are two nodes which have exactly the same configuration in terms of the number of inlinks, and we are reaching these two nodes precisely the same number of times. So that sort of difference is going to happen. So this was about the implementation of PageRank using random walk technique.